Good day and good evening, everyone, depending on where you're listening in from. Thank you for deciding to listen to my presentation titled Streamlining Legislation Using Knowledge Graphs. My name is Joakim Nilsson, and I'm working as a senior consultant and knowledge graph lead for Capgemini. I'm based in Malmö, Sweden, located right next door to the Neo4j office. I've been working with knowledge graphs for the past couple of years, and I've seen a very big increase in the attention and interest in knowledge graph throughout this year. I've been working with knowledge graph both in the private and public sector in Sweden and abroad. I have a background from both mathematics and accounting. This talk will present a POC for which I had an intern from Malmö University, Fredrik Labani, who did a great job getting this moving forward, and the POC is scheduled to be done by December, so still some more weeks and work to be done. With this POC, we envision a solution where an organization could upload a new regulation document along with publicly available information about its own structure, operations, and industry specifics. After running some co-referencing and entity extraction, we feed it into the Neo4j through a local LLM, and then do the same for an organization's publicly available financial statements. The tool would then automatically analyze the content of the regulation, answering 3 key critical questions for the organization. What the new regulation covers, so the tool would provide a concise summary of the regulation, outlining its main points and objectives. This summary would help decision makers quickly grasp the regulation's purpose and its broader implications without needing to comb through lengthy legal text. It will also go into applicability to the organization, so the system would determine whether the regulation applies to the organization or not. This involves cross-referencing the organization's profile, industry sector, operational jurisdictions, size, revenue thresholds, and so on. By automating this step, the organization can save valuable time and avoid the risk of overlooking relevant requirements. And lastly, identification of affected areas within the organization. So the final step involves identifying specific departments, roles, or processes that may be impacted by the regulation. For example, if the regulation imposes new data privacy requirements, the system will flag the IT and the compliance departments, providing a tailored analysis of which actions those teams need to take. This step would enable organizations to proactively allocate resources to the most relevant areas, aligning compliance efforts with the regulation's requirements. And as an example for this POC, we decided to use the new EU legislation, the Digital Operation Resilience Act, or DORA for short, which is a new EU regulation that will apply as of 17th of January next year. So it's a good timing. The aim of it is to strengthen the IT security of financial entities such as banks, insurance companies, and investment firms, and making sure that the financial sector in Europe is able to stay resilient in event of severe operational disruption. And DORA aims to harmonize the rules relating to operational resilience for the financial sector. The reason behind this new regulation is that the financial sector is increasingly dependent on technology and on tech companies to deliver financial services. This makes financial entities vulnerable to cyber attacks or threats, and if not managed properly, the risk can lead to disruptions of financial services offered across borders. This in turn can have an impact on other companies, sectors, and even the rest of the economy, showing the importance of the digital operational resilience in the financial sector. So the more interesting part, this was the motivation behind the POC, but how we did it. So the first thing we did was, of course, to download the DORA regulation from the official EU website. And to be able to work with it, we imported the PyPDF2 library, which enables us to work with the PDF, as was the format of our DORA document. We did some regex, removing line breaks, hyphenated words, and unnecessary spaces. We also choose a chunk size of 1024 characters. We tried with several other sizes, such as 512, but found that 1024 worked best for us. And for the LLM, we ended up deciding on a local Llama 3.1 model, opted for the smallest one due to resource constraints, which worked fine on my computer. But on a standard laptop, it proved to be a bit too weak. So after that, we used a co-reference resolution model. We decided on the co-referee from spaCy to process the input text by linking pronouns and other references back to the entities they refer to. It was a bit challenging to set it up. It was a lot of dependencies that were a bit tricky, but we finally managed to get it working. Co-reference resolution identifies the expressions pointing to the same entity, replacing pronouns like he, she, or it with the entity that they reference. So, for example, as a text here, John Smith, the CEO of TechCorp, announced that the company would expand its operations and stated that the decision aligns with TechCorp's mission to lead AI innovation. CEO emphasized the expansion will create over 500 new jobs and expressed confidence in its positive impact on shareholders. That's the way we normally talk, but in this text, John Smith, CEO, he, and the CEO, they all refer to the same person. And TechCorp, the company, and it referred to the same organization. So without co-reference resolution, extraction might create separate nodes for these references, which will fragment the data and reduce the overall quality. So co-reference resolution enhances the quality of the graph by consolidating entities. So it merges mentions of the same entity into a single node, accurately representing John Smith as the CEO of TechCorp, for example. It strengthens the relationships by consolidating entities, enable a clear, accurate representation of relationships linking John Smith to actions like announced expansion and emphasized job creation. It also reduces redundancy and ambiguity by avoiding redundant nodes. So after we did that, we were looking at named entity recognition in order to extract all entities that were mentioned in the document. In this case, entities such as the European Union or regulation. Regulations are filled with specific entities like organizational names, legal acts, locations, dates, and so on. And as an example, we can look at this text from DORA here, and that by January 17, 25, all financial institutions designated as critical must implement cybersecurity measures in line with the DORA standard and so on. And here we will then get that an organization can automatically extract and categorize dates, entities, frequency, and so on. After that, we moved on to extract relationships between the entities that we found, in this case, relations like governs, supervises, or regulates. We also used the Neo4j vector store and leveraged the integration of vector-based similarity search with graph-based storage. For each document batch, we created a hybrid database combining the vector embedding with graph structure using the Llama embedding model from Hugging Face. And each text chunk was converted into vector representation. To manage a large document, we processed the data in batches. Each batch was transformed into a graph-compatible structure, defining nodes, relationships, and properties. For example, entities like financial institutions were connected through relationships like is subject to or reports to. And in the end, we also created a very simple front end with a Flask application where we could input our questions we want to answer from the RAG application and get back an answer. In this example, we just wanted to start off by asking what the main objectives of DORA regulation are and go back to the main objectives is to enhance digital operational resilience among financial entities, ensuring comprehensive coverage of critical systems through regular testing and improving oversight and regulation of financial entities, which is what we expected. And we did another example here with a more specific question about what requirements are for managing third-party risks under the new DORA regulation. And we get back the answer that financial entities must conduct thorough due diligence on prospective ICT third-party service providers, assess potential conflicts of interest with third-party service providers, and establish a risk-based approach to access, inspection, and audit rights. And that's a very brief presentation, but thank you all for listening in, and I hope it can serve as an inspiration of what you can do with the knowledge graph from Neo4j. If you have any questions or just want to talk about graphs, then don't hesitate to reach out. You can easily find me on LinkedIn, and I hope you enjoy the rest of your day and the rest of the conference. I know I will. So with that, thank you all for your time, and have a nice day.